So now we're going to be moving on to the lesson 7 practice problems, and we're going to be looking at problems that consider 100% and then manipulating it using that 100%. So here we are with our first problem. We've got a bakery. Oh, yummy, I hope they're making me good cookies. And they used 20% more butter this month than they did last month. The bakery used 240 kilograms last month. How much did they use this month? Okay, so if we look at this, we know that if we start with 100%, and we know that 100 is the original, so that would be last month. The 100 is last month. And they're using 25% more, so that's plus 25 because it's more. And I'm adding those together and I get 125%, and that's this month. Okay, and then I'm just going to use my percent proportion to solve this. I know my percent proportion is always is over of equals percent over 100. So is how much. Okay, we know that they used 240 last month, so that's of. So we're finding the percentage of last month. So the of would be 240, that's what would go on the bottom. The is what we don't know, so I'm going to make that an x, equals, and we have our percent, 125, over our original percent, which is 100. Now I know that this confuses some of you to see a percent that's larger than 100, but we do that kind of thing all the time when anything increases. It's just a different way of looking at it. So if we go to cross multiply to solve this, which is the easiest way, you'll always get it right if you just simply do this. I know that I'm going to have 100 times x, and that's going to be equal to 240 times 125. 100 times x is, of course, 100x. That's equal to, and feel free, use those calculators. When I multiply those two numbers together, I get 30,000. And then I always ask myself, what is the opposite of multiplying times 100? Because that's what's being done here. The opposite of multiplying, of course, is dividing by 100. Whatever I do to one side, I do to the other. These two cancel. I'm left with x equals 300, and that's kilograms of butter. There you go. Next, last week the price of oranges at the farmer's market was $1.75 per pound. This week the price has decreased by 20%. What is the price this week? Okay, so again, we know that we always start with 100%. Was, so that's what we're starting with. So the 100 is our original. We're told that it's decreasing by 20%, so that means going to subtract 20 because it's a decrease. I know that 100 minus 20 is 80, and this is the new amount. Okay, so the new amount is what I'm going to be using in my percent proportion. Remember, again, it's is over of equals percent over 100. So is over of. Well, we know that it was $1.75 per pound, and it's going down. So that means my original was my $1.75. So that's going to go on the bottom. The thing I don't know is the part that it is this week. So there's my X equals my percent we found out was 80, and a percent is always out of 100. Now, of course, here we go. We're just going to cross multiply. Easy peasy. So I've got 100 times X equals $1.75 times 80. 100 times X is 100X. Now, I know that the last two problems, this one and the previous one, both had 100 times X. Don't think that's always the way, because it is not. Sometimes something else will be missing. So I just wanted to make sure you didn't get thinking that that's what the case was. Okay, so 1.75 times 80, put that, go ahead and put that in your calculator. You should get 140. And then I asked myself, what's the opposite of times 100? That would be to divide by 100. Divide both sides by 100. I end up with X equals, of course, I always tell you go ahead and use a calculator, but remember in this one, we're dividing by a multiple of 10. There's two decimals there. I mean, 2 zeros there. That means we're going to be moving the decimal that's at the end 2 places back. So that would give us $1.40. $1.40. And that's per pound of oranges. Next, we have Noah thinks the answers to these two questions will be the same. Do you agree with him? And of course, I did highlight this to explain our reasoning, because some of you just like to say yes or no and then walk away. And that's very silly, because you're not going to be sure, and also you're not going to get the points that you want because you didn't explain it and it very clearly told you to. Okay, so the first one. This year, a herd of bison had a 10% increase in population. There were 55 bison in the herd last year. How many are in the herd this year? So a 10% increase. So remember, we always start with 100. A 10% increase means plus 10. So that gives us 110%. I'm going to go ahead and set this up. My 110 is my percent. I'm going to put that on top and the 100 on the bottom. And then I have to say to myself, okay, this year a herd of bison had 10% increase. We have that. If there were 550 in the herd last year, so that's my original. So the 550 is going to go on the bottom. And the thing I'm missing is here in the X. So I'm going to, per usual, cross multiply. And that's going to give me 100 times X equals 550 times 110. 100 times X is 100X. And that is equal to 60,500. I divide both of those by 100 because that is what we're multiplying by. And I find out on this side, those are supposed to be zeros. Let me fix that. Sorry about that. Oh, that's much better. These two cancel out, and I'm left with X equals 605. Okay, so that's my first one. Now the second one. Second one tells us that this year, another herd of bison had a 10% decrease in population. If there are 550 bison in the herd this year, how many bison were there last year? Okay, so this time we've got a 10% decrease. So we take our 100, subtract 10, that gives us 90%. And just like the last one we did, you can go ahead and put that 90, sit it right on top of the 100. Okay, now the next thing we need to figure out is where that 550 goes in this particular problem. It says there were 550 in the herd this year. How many were there last year? So remember, last year is the original. That's the thing we don't know this time. And the 550 is what we have this year, which 550 is therefore the same as the 90%. So, as always, I'm going to cross multiply. So I'm going to have 90 times x equals 550 times 100. If I go ahead and do that math, 90 times x is 90x. That is equal to 55,000. The opposite of times 90 is, of course, divide by 90. Divide both sides by 90. Those cancel. I'm left with x equals. If I do that on my calculator, I'm going to end up with repeating decimal 611.11. So I'm just going to round that to about 611 bison. And this one I did forget to put the label over here for bison. So the question is, do you agree with him? Noah thinks the answers will be the same. Do we agree with him? Well, I don't believe we do, because on this side we have 605, on this side we have 611, so we do not agree. We do not agree. Next, Elena walks 12 miles. She then walked 0.25 or 25 hundredths of that distance. How far did she walk altogether? Select all that apply. Okay, so if I look at this, and at this point, I just want to kind of ignore my choices for the moment and think about what I'm going to do here. So if I, excuse me, if I think about, now this is in a decimal form, not in a percent. So if I think about my 100% as being equal to 1 or 1.00 if it makes you happier, that's my decimal, okay? So of those 12 miles, I know that I'm going to have 1 plus 0.25. So see, it's exactly like the percentage problems that we did earlier, and I was adding and subtracting the percents. These are, remember, decimals are the same as percents, they just haven't been converted. So if I add 1 plus 0.25, that's going to give me 1.25. So if I was thinking about that as a percent, that would be 125%. Okay, so 125% is what we have, and we are finding that out of our 12 miles. So we could use either one of these. So I could have 1 plus 0.25 times 12. I could have 1.25 times 12. Let's see what else we could have. So 12 plus 0.25 times 12. Well, if I use my distributive property, here it is. Woo! Don't forget to do that. Woo! Oh, that was fun. If I multiply that, I'd have 1 times 12 plus 0.25 times 12. 1 times 12 is 12 plus 0.25 times 12. Look at that. There's A. A works. B, if I look at B, I think I have that written right here. And, oh, it's right here. In parentheses, the quantity of 1 plus 25 hundredths times 12. There's B. C, I also have that. Look at that right there. D. Well, 12 plus 25 hundredths. That doesn't even make sense. It doesn't say that she's walking that in miles. It's saying 25 hundredths of the distance, referring to the 12. So therefore, that doesn't work. And 12 plus, well, if I were to do this, I'm ignoring my distributive property like I did here. So that's also not correct. So my correct answers are A, B, and C. And then finally, we've got the equation D is equal to 3t, representing the relationship between the distance D in inches that a snail is from a certain rock. Oh, snails go awfully slow. and the time it takes in minutes. So it's asking you in this expression, or equation, excuse me, what does the 3 represent? Well, it tells us that the d is the distance in inches, and it then tells us that the t is the time in minutes. So I'm multiplying 3 times t. Well, what logically would I multiply times the number of minutes? I wouldn't multiply a number of minutes times the number of minutes. That makes no sense at all. So therefore the 3 represents the distance, or in this case inches. It's 3 inches that the snail travels per minute. You see, and that's why the t here, 3 times t, 3 times the number of minutes, gives us the distance. How many minutes does it take the snail to get 9 inches from the rock? Okay, so this is a very simple substitution. I know some of you are still a little confused about that, but we take our original, let me do this, there we go, our original equation, and in this case our original equation is d equals 3t. I'm going to put a semicolon to separate my 2 parts. And then this is 9 inches. So is 9 the distance in inches, or is it the minutes? Well, it tells us right there it's inches, so it's for sure the distance. So therefore they're telling us that d is equal to 9. So I just substitute in. Every time I see a d, I'm going to put a 9. So I've got 9 equals 3t. Well, now it's a very simple one-step equation that you should know how to solve. Right here, it tells me that we're multiplying t times 3. What's the opposite of times 3? You should know that that's divide by 3. Divide both of these by 3. Those cancel. I'm left with t. 9 divided by 3 is 3. So the answer for the second one, how many minutes does it take? It takes 3 minutes for that snail to get 9 inches from the rock. That's a really slow snail. Well, I don't know if it's a slow snail. It's just really slow. I don't know how fast snails go. I suppose that's something you could look up if you were interested. Okay, next one. How far will the snail be from the rock after 9 minutes? So in this case, it gives us the 9 minutes. So we are still using the exact same equation and substituting in. So you've got d equals 3t. I'm going to separate the 2 parts with a semicolon. 9 minutes. So is that the distance? Distance is in inches. Clearly not. It says minutes. So that means it's going to be t for time. So t equals 9. Now wherever I see a t, I'm going to substitute in a 9. So I'm going to have d equals 3 times 9. I know it didn't exactly line up, but hopefully you understand that isn't going over here. It's really going over there. That's my t. And then this is far easier to solve than the other one. Not that the other one was hard, clearly. I'm just going to simply multiply. D is equal to 3 times 9 is 27. And I know that 27, how far would the snail be? It will be 27 inches from the rock. There we go.